All right, students. So this week we're going to talk about similarity in right triangles. So we're going to look into the geometric mean also. If you guys remember how to do proportions, this is a good way to remind you. We're going to be using proportions here a lot. So notice that there are three triangles. There's that big one, right? There's this one, the medium one, and there's a little one here. So we have ABC is similar. This is the symbol for similar. ABC, so the big triangle is similar to the medium one, which is ADB, which is similar to BDC, which is the little one, BDC. Okay, and they all happen to be right triangles. Now it says, identify the similar triangles in the diagram. All right, so same thing here. So we have the big one, which is PQR, so PQR, so this triangle, the big one. Then we have the medium one, which is PSQ, that's a medium one over here. And then we have the little one, QSR, so QSR. Notice that the middle letter is where the right triangle falls, right? So this would be the right triangle, okay? All right, so with that, we keep going. It says directions, find the value of x. So if you remember how to do proportions, we're going to be doing proportions here. So notice that we can say that there are three triangles in that diagram here, but we're going to be using two. So the first triangle that we're going to be using is the outside, which is this one. Now, this is the leg and this is the hypotenuse of that triangle, which is the big one. Now, how do I know this? Because this 12 right here is the hypotenuse for this side over here. So the sides are equivalent. So this side is to this side. So this side is the same as this side, proportional, the same. It's a similar, the position is similar to this position, basically. So 9 is to 15 what x is to 12. That means that 15 is the hypotenuse of this big triangle and 12 is the hypotenuse of this smaller triangle that's inside, okay? And if you remember how to do proportions, we are going to use the butterfly method, and then we multiply. 9 times 12 equals 15 times x. And then we multiply and then divide by 15. So let's do that. I get my calculator ready. So that is 9 times 12. That is 108. And then divided by 15. We divide by 15. So divided by 15. And I get 7.2. That means that x equals 7.2. Okay. All right, same thing here. So let's see. We have this is big. This is the big side. This is the little leg of that big side. And this is the little leg of that hypotenuse here. And this is the hypotenuse. So 11.2 is to 23.8 as x is to 21. That means that 23.8 is the hypotenuse of this little side, and 21 is the hypotenuse of this little side, this internal triangle here. So let's do that. Let's use the butterfly method. We're going to multiply the two numbers and divide by the one with the x. So that would be 11.2 times 21. I get 235.2 divided by 23.8. I get x equals 9.9. I'm going to use just one decimal point. All right, so next one here. So we're going to be using, let's see. So this is the hypotenuse, 25. is to the bigger leg, right? This one? No. Is it? No. So 25. So let's look for the smallest one first. That's a trick. All right. So let's look for, so this is the small leg, and the hypotenuse of the small triangle inside is 24. So x is to 24 what 7 is to the big hypotenuse of the whole triangle, which is 25. And then I'm going to multiply these numbers and divide by the one with the x. So I have 24 times 7 equals 168 divided by 25. And I get x equals 6.72. I can just write 7.2 or 6.7. And that's it right here. All right. So this is when you're looking at similar triangles. Now let's move on to another concept called the geometric mean. So when you're looking at the geometric mean, we are also using proportions, but there's a simple way just to kind of work with the formula and make it easier. So it says the geometric mean of two positive numbers, A and B, is a positive number x such that A is to x as x is to B. So x, so therefore x squared, so if you play with this formula, we get that x squared, there are two x's, right? X squared equals A times B, which if you take the square root of the x squared, we take the square root of both sides, we get x equals x square root of A times B. And it says direction. So find the geometric mean of each pair of numbers. Let's do that. So using this formula, because we derive that formula to that, which it makes it easier, we're going to multiply them, 6 times 30, and then take the square root of that. You can just do that in the calculator, people. Let's do that. We get 6 times 30 equals, and then take the square root. We get 13.4. 13.4. And that's it. That's all you got to do here. Next one, 16 times 28 equals, and then take the square root. That's 21 point. So that's 16 times 28, and then take the square root. We get 21.2. Definitely just use one decimal point. That's okay. And then 12 times 50 equals, and then take the square root. 24.5. So that's 12 times 50, and then take the square root of that. All right, so that's the geometric mean. Pretty simple, right? Awesome. Make sure you're rounding correctly here. So notice that 24.49 is 24.5. Okay. All right. Then we move on to, there are two different theorems that we're going to touch base. It's the geometric mean altitude theorem, which is the altitude is this line over here, right here, the altitude of a triangle, okay? That it's from the vertex to the bottom, to the base of the triangle. So we use that for area, right? Remember how to take the area of a triangle? We use the altitude, right? So it says, geometric mean altitude theorem. The length of the altitude is the geometric mean of the lengths of the two segments. So this length and this length right here. So notice that that squared equals AD times DC. That's all it says here. So that is, they're giving you the formula here. So it says directions, find the value of x. Here you are looking for the altitude. So because the formula says that, we're going to be looking for the altitude. So that is x squared equals, because that's x squared, equals AD. So this piece times this piece. So that's 12 times 8. Now let's do that. So that's x squared. 12 times 8 is 96. And then you take the square root. So take the square root of 96. I get x equals 9.8. And that is my altitude. Pretty simple, right? All right. Don't forget to take the square root there. All right. So then here we have a variation here. So they're saying that the whole piece is 37. But remember, you need this piece and this piece. So that means that if we subtract 37 plus minus 5, we get this piece over here. So let's find that. So the first step, 37 minus 5, that is 32. That means that this side right here is 32. I'm going to write it here so I know. So this is 32 and this is 5, right? And then 32 plus 5, it gives you the whole thing, which is what they're giving you. But you don't need the whole thing, right? All right. So then we have x squared equals 5 times 32. Notice that you can mess up here because you can put that 37 times 5 and it would be wrong. 5 times 32, that is 160. And then you take the square root of that. So x equals, the square root is 12.6. 12.6. And that is the altitude. So notice what they're giving you and what they're asking you for, okay? All right, so say about this one right here. They're giving you the altitude. You're not looking for it. So if they're giving you the altitude, it's 18 squared equals, well, x is this piece times this piece, right? So that's x times 15. If we do some algebra, that would be 18 squared equals 15x. Remember, you divide by that. But first, you got to find what 18 squared is. That's 324 equals 15x. Oh, that's algebra, people. You divide by 15 and you find x. So that would be 21.6. And that is this piece that you're missing here. So notice that here you are missing the altitude. Here you are missing one of the pieces that to the puzzle here. So one of these little pieces, okay? Now this one is a little bit like, what? Well, notice that you're not gonna get one like this. So I'm probably gonna skip this one for now. So let's move on. Let's move on to the other one because we still have one more theorem to go through, and it's the leg theorem. So the length of a leg of the triangle is the geometric mean of the length of the hypotenuse and the segment of the hypotenuse adjacent to the leg. Adjacent means next to. So what does that mean? We have the little leg and the big leg, right? So this is the big leg. So AB right here, AB squared equals AD, which is the leg adjacent to that leg, and then AC, which is the whole thing. Notice that. See? So AB squared equals AD times AC, which is the longest leg. Now the other leg, which is the little leg, is BC, right? So BC squared equals this little leg over here, which is the adjacent, times the whole thing again. So let's work. I know it's kind of crazy to look at it that way, but let's do some examples. So say as an example, you're not going to have anything like this or like this. Let's do one of each here. So it says the long leg, we're looking for the long leg. So we're going to be doing this one. Okay, so this is for the long leg and this is for the short leg. Okay, so the long leg. So this is the long leg of the whole triangle here. So the long leg, it's the long leg squared equals the one adjacent to the long leg, which is next to it, times the whole thing. So we got to add 24 plus 2, that's 26, right? That's the whole thing right here. Okay, so 24 times 26, which is the whole piece. So 24 is the adjacent leg to the adjacent piece to the long leg. So let's look at that. So we get 24 times 26. How much is that? 24 times 26 is 624. Whoops, sorry guys. 624. And then you take the square root. So take the square root of that. And you get x equals 24.97. You can say that is 25. Round. All right, next leg, the last leg is the little leg. This is a short one, so we're gonna be using this one. That means that we're gonna be using the whole thing. That's great because we need it, but we need this piece too because that's the leg, that's the piece of the hypotenuse that is next to the short leg. So 12, so we need to find that little piece here, that if the whole piece is 12, 12 minus 7 will give you that little piece here, so 5. All right, so once we have that number, that's the one we need. We need 5 and we need 12, the whole thing, because of the formula, right? So that is x squared equals 5, which is the piece of the hypotenuse right next to the leg, and then the whole hypotenuse times 12. So 12 times 5, that is 60. And then you take the square root of that. X equals, take the square root, that's 7.7. 7.7 is the short leg. Okay. All right. I hope this helps. See y'all.